Hello everyone. In this video we will learn regarding something called as different types of signals that we have in networking and telecommunication. So in this video we will learn regarding two types of signals that we have. One is called as analog signals and another one is called as digital signals. So let's learn one by one what is analog signal and what is digital signal. So first let's learn different pointers for analog signals. We will understand both the types of signals using the graphical representation as well as how they are represented when we transfer from one point to another point, and what is the difficulty in either of the case when we transfer from one point to another point, analog signal as well as digital signal, and what are the advantages of each other over analog to digital or digital to analog. Okay, so what is an analog signal? Analog signal is a continuous electrical signal. So let's note down, it is nothing but it is continuous electrical signal. Now these are varying continuously in amplitude and frequency. So let's understand in the graphical representation. So what happens is, let's say it is varying like this. Okay. So this is our frequency and this is our amplitude. Now, analog signals can have infinite number of these amplitude values that you have. So here we have infinite number of values within that specified range. Okay. So in analog system, it is difficult to remove the noise when we transfer from one point to another point, or we have many wave distortion that we have. So during the transmission of analog signal from one point to another, let's say point A to B, when you are transferring your analog signal, you cannot remove the wave distortions that we have here. For this reason, this analog signals cannot perform high quality data transmission. So here the disadvantage we have, let's say disadvantage we have here is, for long distance transmission we cannot send over long distance, and it cannot perform this high quality data transmission. So when we try to send from one location to another location, this you will have multiple wave distortions, as well as we cannot remove the noise. Okay, so this disadvantage is because we cannot remove noise, and we have multiple wave distortions. So because of these reasons we cannot use analog signal for transferring our data transmission in long distances. Okay, so this is how it is picturized. So in this format, this is how your analog signal is picturized. So example of these can be, let's say, the temperature of a place. For example, let's say the temperature at this location in Bangalore, so it varies at any point of time. So example of this can be, let's say, temperature or humidity. So it keeps on changing as per any point of time. So we have uh, the thermal the temperature of this place, they keep on varying. Now if you are representing with let's say a digital thermometer or something, we cannot represent, we have to have that. That's what the term digital when I am getting in. So we have that, we have a fixed value. Here we have continuous value. We will see how it is different from the digital one. So let's now go to the learning what is digital signal. Okay, how it is different from the analog one. Okay, in the digital signal, here also the definition wise, digital signal, it is also electrical signal, but here we have just two distinct states. Okay, so these electrical signals, we just have two distinct states. Either it can be on or it can be in off state. Okay, or you can also call as positive or negative. Now the most fundamental and widely used form of digital signals are nothing but the binary signals that we have. It can be 0 or 1. Okay, so these are the basic binary signals that we use for representation everywhere. So in which one of that represents the amplitude condition, represents binary digit 1. Okay, it can be binary digit 1 where it is like if you take from this 0, it can be 1 or it can be 0. So it is this way it is represented. It can be 1 or it can be 0. So this way. Okay, and in noise and distortion have little effect in this case. Okay, that when we compare to the analog. So in this case, this noise or distortions have like very little effects. So that is why we will be able to send these signals from one point to another point in not much distortion or without any much noise when we are trying to send in case of digital, because it can be either 1 or 0. So it is easy to transfer all our signals because it can be either on or off. But if it is a continuous pulse that we have seen in the previous case, it is very difficult to send. Later we will discuss how these are analog signals are converted to digital. We do different process, we call them as sampling, then we quantize the signal, then we convert it to zeros and ones, then we transfer. Okay, so it becomes very difficult to send in analog format. We convert the signals from analog to digital, then we transfer. Okay, now let's understand how they are picturized. Okay, so here also let's draw the pictorial format like we had done for the analog signal. So these are not continuous, but it has a discrete uh, states that or the values. So it can be either zeros or one. So the blank space that you see, they are zeros, and the one which has the amplitude or which is on or positive, they are one. Okay, so in this we have the frequency, and on the x-axis we have the amplitude. Now once we have got the difference of analog signal and digital signals, now let's learn regarding how this analog to digital conversion happens. Okay, so let's learn how the analog to digital conversion happens. Analog to digital conversion. Okay, so this analog to digital conversion is a process which continuously this variable or analog signal is changed without altering its essential content. Okay, so this is nothing but a process where these continuous signals that is coming, what you do, it has to be converted to your discrete format. Okay, I am taking as an example. Okay, it can, don't take in a literal fashion of conversion. Okay, so for example, let's say we have taken a sine wave. Now in the real case scenario, what happens is a codec, or it is called as codec, it is coder and decoder. This device transforms the analog signal to digital signal. Okay, now this process of conversion requires three steps. The first one is called as sampling. Then the second one is called as quantizing or quantization. And the third process is called as digitizing or digitization. Now let's learn each of the steps one by one. So the first step, that is called as sampling. Now the sampling process, what happens in this case is, so the signal that you have taken here in this case example, so these are sampled, and they create pulse, so each representing the amplitude of the signal. So for example, let's say I'll draw a picture of sine wave. So we have to sample these at regular interval. Okay, so let's say you have a certain frequency, and these are your amplitude. Now we use Nyquist criterion. I will cover in different video what is Nyquist criteria or Nyquist theorem. Now this says that the sampling frequency should be your double the frequency that you are trying to send. Okay, then only you will be able to recreate these signals at your destination. So Nyquist criteria says that the sampling frequency should be twice the frequency that you are sending. Okay. So this is your sampling frequency. So this is your, I'm writing representing this as Fe, and this is our sampling frequency. So it should be double the this sampling. So the sampling rate should be double the frequency that you are trying to send. Then only we will be able to create this signal at your location. Okay. Let's learn about the second process that we have. It is called as quantization. Now, quantization is a step where you have this, basically during quantization, a discrete amplitude value that closely matches the original sample is used to represent the value of the pulse. For example, let's take the same example that we have. So once our signal is sampled, let's say we have created these samples. Okay. Now what we have to quantize the signal, whether, let's say for example, it was 1, let's say this is 0.1, this is here 0.2. Now each of them will lie at certain location. So you will tell that if it is between 0.5 or less than that, it will be 0, or if it is more than that, more than that more than 0.5 or equal, I will take it as 1. Okay, so this is how you quantize. Now digitization process, the last one that we have, is nothing but you have to convert all your sampled signal after quantization into zeros and ones. Zeros and ones. Okay. Now your signal will be represented, that all that we have, the continuous signal, it will be represented in discrete format. It can be 0 1 0 1 1 1, so in this format. Okay. So all the signals that you have got, it can be 0 0 1 1 1 1. Okay, so for example, I had taken here, so all that lies as per your quantization method, it will be represented this way. So it can be 0 1, or it can be this way. Okay, so this is how it is represented. Now from the next video onwards, I will discuss regarding what is called as uh, how we got the voice signals. So what is the sampling rate and how we get to, we just hear that it is 64 kbps that we use for the voice channel. Okay, the speed for the voice traffic. So how do we get it to here? So we'll start from here, then we'll go on to the topics such as multiplexing and what are different types of transmission types. So those things I will discuss in the next video. Till then, bye bye and happy learning.